Next topic is potential energy. Potential energy. Energy is stored up energy, stored up work, stored up work in a body. Now we shall concentrate about the especially gravitational potential energy. Gravitational potential energy. Now, what is gravitational potential energy? Suppose there is a body of mass m lying on ground. This body is on the ground. And ground is taken here, the reference plane or reference surface. We know a body of mass m, suppose the body of mass m is acted upon by a force due to gravity, force of attraction, force acting on this body or a mass is equal to m into g, where g is equal to acceleration due to gravity. It's a force and it is termed as weight of the body. So when an external agent, suppose an external agent pulls the body upwards, so the external agent will have to exert a force. F dot is equal to F is equal to mg. Same amount of force should be applied here to lift this body from this ground or reference plane to a height, say h. So this is the point B and this is point A. This body M, the body of mass M, is lifted through a height h, by an external agent, and the external agent exerts a force mg, and under action of this force F dot, the body moves through h. So the work done by the external agent, the work done by the external agent to lift the body through a height h would be equal to work done. So work W is equal to force into h is equal to mg into h. So this amount of work, mgh, amount of work, is stored up work in the body. When the body is being lifted from point A to point B by an external agent, the work is done and this work is stored up in this body, and amount of work is equal to mgh. That is why this amount of work is known as the potential energy of the body at this position. So potential energy PE is equal to mgh. Now we can say the potential energy of a body is due to its position. At this position, the height of the body from ground is equal to 0. So at the bottom or on the surface of the earth, the gravitational potential energy is equal to 0, and when the body is lifted up to a height h, the potential energy becomes mgh. So this is the simplest idea about gravitational potential energy of a body, though the idea is rather complicated, and in higher classes you will have to learn the complicated idea. Now it is necessary for your class 9 course. So we have discussed previously about the kinetic energy, and here we have discussed about potential energy. EP is equal to mgh. Now if this is the reference plane, ground level, reference plane is ground level. At a height h, the potential energy is equal to mgh. M is positive, g is positive, and h is also positive here. So potential energy is positive. If the body is taken to this point C, this is A, this is B, this distance is h dot, then the potential energy of the body at this point, m into g into h dot, but this would be negative. So potential energy of a body can be 0, can be positive, can be negative, but kinetic energy, expression for kinetic energy is equal to half mv square. Half cannot be 0, cannot be negative, m cannot be negative, and v square, a square term is always positive. So kinetic energy is always positive, but potential energy can be positive, can be 0, can be negative. So this should be remembered during problem solving and other purposes. Now we are going to prove a very important theorem for class 9. That is, the proposition of the theorem is, for a freely falling body, the total mechanical energy is constant. This proposition or this theorem or this statement is very important for class 9. Now, freely falling body. Suppose there is a tall building. This is the building. This is the ground or reference level. This level, at this level, any body has 0 potential energy. So this is a tall building. There is a mass of a body is equal to m. a body of mass m is placed here. The height of the building is capital H. Height of the tower or building, height of the building is equal to capital H. So we can say the potential energy of this body at the point A. This point is A, suppose this point is B and this point is C. The topmost point is denoted by A, another point B that is in between A and C. This is bottom, ground level. The potential energy of the body at point A is equal to mgh, and kinetic energy of the body at point A is equal to 0, because the body is resting here, the body is at rest, there is no velocity. So v is equal to 0 and v is equal to 0, half mv square is equal to 0. So kinetic energy of the body at point A is equal to 0. Now the mechanical energy is the sum total of potential energy and kinetic energy. So we can say the total mechanical energy of the body at point A is equal to potential energy plus kinetic energy, EP plus EK is equal to mgh plus 0 is equal to mgh. Now, let us suppose the distance between A and B is equal to h. Distance between point A and point B is equal to h. So when the body falls from point A to point B, freely falls, the height of the body becomes this, and this distance is equal to h minus h, because it is h. So we can say the potential energy of the body at B is equal to mg, in place of h, here we take h minus h. So this is the potential energy at the body. The body is falling freely. The body is falling freely. So the velocity attained by the body at point B is v. We say the body falls freely from this point to this point, and due to free fall from this point to this point, the velocity attained by the body is equal to v. So v is the velocity attained by the body due to free fall. We know when a body falls freely means at this point velocity is equal to 0, at this point velocity is equal to v, the distance, vertical distance traveled by the body is equal to h, and we know during free fall, the equation of motion of the body becomes v square is equal to u square plus 2gh, where g is acceleration due to gravity and h is equal to height through which it falls. And as the body falls freely, we can say velocity of the body, initial velocity u, is equal to 0. So v square is equal to 0 square plus 2gh square. So we can say the body is falling freely, so that the velocity attained by the body at point B is equal to v, say, and we can say or write down v square is equal to 2gh. So kinetic energy at point B is half mv square is equal to half m. V square means 2gh. 2 cancelled is equal to amg small h. Okay. So kinetic energy at the point B is half mv square is equal to mgh, and potential energy was mgh minus small h. So the total energy, again the total mechanical energy is equal to potential energy plus kinetic energy at point is equal to mg capital H minus small h plus mg small h, and it is equal to mg capital H. The total mechanical energy of the body at point A was mg capital H, and the total mechanical energy at point B is equal to mgh. So we can say the total energy at point is equal to mg capital H, and at these points also the total mechanical energy is equal to mg capital H. That means no loss of energy. At this point, the total mechanical energy is equal to mgh capital H, and at these points also the total mechanical energy is equal to mg capital H. Now we consider the third case. That means when the body touches the ground. That means just at point C. So these are unnecessary here. Here we consider third case. The velocity attained by the body just before touching the reference plane or ground. So the body travels or falls freely through a distance A to C, and we know the distance A to C is equal to capital H. So when a body falls through a distance capital H, the velocity attained by this body, just before touching the reference plane, is equal to capital V, say. Now we calculate what is the value of V. We know the equation of motion, V square is equal to U square plus 2G, in this case capital H. If velocity attained by the body just before touching the ground is equal to capital V, then V, it touches the ground after traveling distance capital H, and due to this distance traveled, the velocity attained is equal to v square storage, and u, initial velocity, is equal to 0 in this case also. So we can say v square is equal to 2gh. Where? So where? Right here. Where v square, capital V square, is equal to 2gh. So the kinetic energy of the body at point C, just before touching the ground, is equal to half m capital V square is equal to half capital V square is equal to 2gh is equal to mgh. And just before touching the ground, at this point, the distance between ground and the body is equal to 0. So potential energy of the body at point C is equal to mg into 0 is equal to 0. So total mechanical energy at point C is equal to Ek plus Ep is equal to mgh plus 0. That is equal to mgh. So the total mechanical energy at this point is equal to mgh. Now we can say for a freely falling body, the total mechanical energy is constant, and that is equal to mgh. So we conclude for a freely falling body, the total mechanical energy, that is the sum total of kinetic energy and potential energy, is constant. Remember here, during reduction of this principle, we have neglected the resistance due to air. We have neglected here. We have neglected the air resistance. Though freely falling body means these words are sufficient to denote that we have neglected the air resistance. This is for meant for class 9, but the advanced students may learn another principle, that when a body falls freely through an inclined plane, the total mechanical energy remains constant. Now deduce another, you do it yourself. If you cannot do, I will discuss it later. Prove that the total mechanical energy of a body moving along an inclined plane. The total mechanical energy of a body moving along an inclined plane remains constant. So you have to prove just like this inclined plane, this plane is inclined plane, a ball of mass rolls down along this inclined plane, and you have to prove the mechanical energy at this point, total mechanical energy at this point is equal to total mechanical energy at any intermediate point. This may be this or this or this or this or this, any one of these positions. And so this is point A, this is point B, and this is C. You have to prove it. You have to prove the total mechanical energy of this body at this point is equal to the total mechanical energy at this point is equal to total mechanical energy at this point. For sake of your proof, you may take it as theta, and this height is equal to capital H. Now you prove yourself. Thank you for attending my class, and in future or in next class I shall prove this. If you cannot do this, prove that the total mechanical energy of a body moving along an inclined plane, moving freely, though one should be moving free, along an inclined plane, smooth inclined plane, remains constant. Okay.